Assalamualaikum warahmatullahi wabarakatuh and good morning.
Waalaikumsalam, Ustaz.
Waalaikumsalam, Doktor.
Okay, ready Today we are going to continue with our discussion. Okay. Uh, so this week we are going to cover chapter 5, which is a new topic, loop logic structure. Right. So from its name, I think everyone will know, right? This one will be involving a repetition. Okay, a repetition in the program that we are going to design. Okay, loop and loop is a repetition. Okay, right. So why do we need a loop in our program? So mainly why we need loop is to optimize our program. Okay, so to optimize our program. So that one is in general. Okay, so why we need loop? We need loop to optimize our program. By the means of optimize, okay, optimize meaning that we want to apa? Let's say if we have a hundred line of coding, okay, for a program. So by applying looping, so we hope that we will be able to reduce, okay, from hundreds of lines of codes. So maybe we can optimize the codes to less than 100. Okay, so that's what's the means of optimization lah. Okay, codes optimization. Okay, so if a program that you design doesn't have a looping, then maybe then for sure it's going to be a longer program, and also in terms of execution time. Okay, execution time meaning that when you run the program, so the in order for the program to respond, okay, to the user, is going to be much more longer. That can lag lah. Okay, possible for lagging is high. Okay, if you have a very long program, okay. So that one in general, why we need loop. So in much more details, why we need loops. So you can download the notes. So notes, probably I'm not going to explain this chapter 100% based on notes, because I'm afraid that maybe some of you will find it a little bit confusing. Okay, so I'm going to straight away refer to examples, and from that we are going to build up our knowledge about the looping. Okay, okay, but in general, looping is for optimization. Okay, codes optimization. In details, why we apply loops is because we want to do these two operations. Okay, uh, these two operations. Okay, first is we want to do what we call as accounting. Okay, counting. Counting in Malay apa? Apa?
Mengira.
Mengira kan? Okay, counting. So what do we want to count? Okay, it can be anything, but mostly, okay, mostly the one that we want to count is we want to count how many times the loops happen. So how to do it? By implementing this equation. Okay, counter equal to counter plus 1. So this is a very you can apply this equation in any program that involving accounting. So like I said, in details why we apply why we need looping in our program. So the first one is to do counting. So how to do counting? By applying this equation. So just put this inside of your program. So meaning that you already apply a counting technique. Okay. So next is accumulating. Accumulating is you want to accumulate. Accumulate macam mana dekat? Accumulate. Okay, so this is not the general equation for accumulate. For accumulate, the general equation is total equal to total plus what do you want to accumulate? Let's say I put it as X. The one that you want to accumulate. Okay, let's say you want to accumulate a mark. Okay, so let's say we have 10 students. So we want to accumulate all the marks for 10 students. So we put mark over here. Okay, so let's say you want to buy not buy. Let's say you want to, okay, let's say we use buy. Okay, so let's say we want to buy 10 pen. Okay, each pen have different price. Okay, so we want to add together all this price. So we do accumulating by using this equation, but we change this to pen price. Okay. Okay, another example. Let's say we want uh to calculate the what else? The salary. Okay, salary for 5 worker kan. So let's say we have 5 staff. Each staff have different level of salary. Okay, so we want to accumulate all 5 staff salary. So we put over here what class? What should we put over here?
Salary.
Salary. Okay, so you got it, right? So this is a basic, okay, basic equation for accumulating. So I put it like this. Okay, X you may change to whatever that you want to accumulate. Okay, please remember this. Please remember these two equation because this is very important and it will 100% give you marks. For sure, you will get marks in terms of application of looping. Let's say if the question asks you to apply looping in your program. So let's say if you put this, for sure you will get some mark. 1, 2, 3 doesn't matter. Okay, based on the problem. Okay, they recommend. Then if you apply accumulating to your program, okay, for sure you will get marks. Okay, for this. Okay, so this is the in details. Okay, why we need to apply looping. Okay, these two. Okay, counting and accumulating. So this is counting. This is accumulating. Okay, now so let's get to an example. Okay, so but before that, let me get back to this. Okay, so this chapter will cover introduction to loop logic structure. So basically there are 3 types of loop, okay, that we are going to look. The first one is while loop. Okay, the second one is repeat, repeat until, or we usually call it as do while. The third one is automatic. or we call it as for loop. So there are three types of looping that we are going to see. Okay. So the purpose is similar, however, the structure is different. How we write it, okay, in terms of algorithm, in terms of flowchart is different, but the purpose is similar. Okay, we use these three either to do counting, or we apply it to do accumulating, or we apply it to do both. Okay, counting and accumulating. It can be both, can be either one. Alright. So next we are going to look at, so this one after everyone understanding, after everyone already understand the first part. Okay, so we are going to go to this. Okay, PSC, IC, IPO. If let's say the problem involving loop. Okay, and then this one part 4. Okay, let's check for loop. This is actually easy. You can see it from the example. I think straight away you will understand. Okay, right. So moving to the example. Okay, make sure you really understand. Okay, this chapter. Because this will be used not only for this semester but throughout your study in UMP. You will see looping everywhere. Okay, make sure you understand. Okay, so look at this algorithm. So this is a simple algorithms. Okay, please look at this first. Okay, tell me what does this algorithm do?
Sum.
Yeah,
Tambah.
tambah. Okay, tambah apa?
Semua.
How many numbers?
5.
5.
Okay, so first user need to enter 5 numbers. Yeah. Anybody want to speak? Apa nak cakap ni? Ada bising Dengar tak?
Dia macam ni cengkerik ni.
Tak ada dah. Okay. Okay, so imagine. Okay, so right now we have 5 numbers. Okay, need to entered by user. Okay, these are the numbers. So first number will be stored in N01, second N02, and so on. After user entered these 5 numbers, then the system will calculate the sum of these numbers. Okay, finally it will print sum. Okay, the value of sum. Okay, so imagine, let's say we have 1,000 numbers that need to be entered by user. So how long is your program is going to be? 1,000 number, kan? So can you imagine the problem? Not will be faced only by a programmer, but also by the system itself, kan? So you are going to need at least minimum 1,000 line of algorithm, kan? Flowchart, 1,000 symbol of flowchart minimum, kan? So that's the problem that we are going to face. So in order to avoid this kind of problems, we must apply looping. Okay, so how to identify where to apply the looping? So you need to identify which one, which process is repeated. Okay, let's see if you already come up with, you already extract all the information and using PAC, you identify what is the input inputs, what is the calculation, what is the output. So you can identify actually what process is repeated. Okay, for example, we can identify this is repeated. So this is a repeated process. Okay, user need to do the same thing. Okay, another one is this one. So this is also repeated process. Okay, we add. Okay, add number one with number two, number three. So this is repeated. So group all these repeated process. Okay, identify and group it. Okay, group it. So let's say, okay, let's say we have very uh, let's say if you have difficulty in identifying, say, which process should be put inside of loop, which is not. So you do it manually. Okay, do it step by step. So identify, and then what you need to do is you need to choose. Okay, you need to choose which loop structure that you want to use. Okay, so earlier I said that there are three types of looping. Okay, so the first one is while loop. So let's say you already choose while loop. Okay, so what you need to do is, okay, you need to write down while. The keyword is while. Okay. Okay, the keyword is while. Okay. And then there should be a decision maker over here. Okay. Decision making over here. The decision to determine whether the system should repeat the process, okay, the following process or not. Okay, let's say we put it later. So we classify all the repeated process by putting a indent. So we put an indent over here. So this all repeated. Okay, put an indent. Alamak. Okay. So this is not repeated, right? So we put it the same level with while. Okay, next we close. Okay, don't forget to close the while with while and. Or you want to put and while also can, and as long as we understand. Okay. So first you must have the words while, and then while and. Okay. Okay, next we must put a decision to the while. This decision will determine whether we must stop the loop or we must proceed with the loop. Okay, this will control the loop. If you put the wrong decision, most probably you will get infinity loop, where your programs is looping with no stop. Okay, for example, supposedly user need to enter only 5 numbers. Infinity loop is user need to enter numbers infinity, enter infinity. Okay, until you drain your memory. Okay, your CPU memory. It will drain your CPU memory. So this is also one of the technique used by the hackers, to to make a system slow. So apply infinity loop. All right. So make sure you properly design the decision over here. So let's say, okay, let's say uh, we want the program to be able to loop 5 times, okay, because user need to enter 5 numbers, right? So the program should be repeated 5 times. So what you can do is you can put one variable, okay, any variable name you can apply over here. And then we can put it like this. Say if counter is less than 5, less than 6, so it will repeat. Okay. Okay. First we apply counter over here. So it can be any names. For example, you use uh, X, but of course, uh, variable kan, variable should be understandable kan. So cannot lah. X kan. What else name? Doesn't matter. You think about it later on. Okay. So let's say we use counter. Okay. Counter must less than 6 in order for the repetition to be happen. So what happen is if counter equal to 6, is it going to repeat or not?
Not.
So logically,
Not.
the system is not going to repeat.
No.
Okay. So counter value must less than 6. All right. So this is the decision along with while. Okay. After while, you must put decision that control the loop. Okay. Control whether the system should continue looping or should end the loop. Right. And then after you finish putting the decision, you must put initial value of the decision maker. So in this case, our decision maker is counter. Okay. So you must put initial value of the counter. So in this case, we are going to put 1. Okay, why we put 1? Okay, we will look after this. Okay. So this is the starting point. Okay, starting point of the looping. So somewhere we must start with a number, kan? Otherwise, after your system, after your compiler read this one, the compiler will not know. Okay, what is the value of counter, kan? So we must put initial value. So this is the initial value of the counter. Okay, let me put over here. This is a side note. Okay, don't put it in your algorithm. Okay, this is initial value of counter. Okay, usually we put 1. Doesn't matter. It's up to you. But normally we put 1. You can also put 0. But debat lah. Okay, so we will look at the effect. Okay, whether you start with 1 or 0, we are going to look at the effect later on. So up until here, we have the value of starting point of the counter. You must have this value. Next, we must have decision involving the counter. Okay. Next is inside of the loop body. So the red one, okay, the one that we put an indent over here, meaning that all the process within this indent is belong to the loop body. So what effect will cause all this process? So all the process within the loop body is going to be repeated. Okay, as long as the decision is true. Okay, as long as the decision is true, all the process within the loop body is going to be repeated. Okay, up until this point, you can understand, right? Okay, so next step is we need to put an update to this counter. Okay, so first we need to have initial, and then we need to put a decision. Okay, finally at the bottom of the loop body, at the bottom kan, at the end of the loop body, so this is the loop body. At the end of the loop body, you must put You remember this equation? What does this mean? What is this, class? Equation for what?
Counter total. Counting.
For counting. Yes, correct. So again, this is side note. Okay, don't put it in your algorithm. Okay, this is just to put a note so that you know what is this, eh? So this is counting. Okay, so why we need counting? Okay, so later on I will explain. Okay, later on we will test this algorithm and you will understand. So this is the basic. Okay, basic elements that we need inside of a looping. So counter initialization, counter decision, and counter update, or we call it as counting. Okay, this is for update, actually, to update the value of counter. Okay, next step is to simplify the process. So since we already applying looping, so anything that involving a repetition process, we need to simplify it. Otherwise, there's no use to apply looping, right? We want to apply looping to make this process optimized, kan? So identify which process is repeated. Okay. So from this, choose one variable that can reflect all variable. So we have no 1, no 3, no 1, 2, 3, 4, and 5, right? So in general, this is what? This is an O, kan? Or number, kan? So you can make it general variable. No need to be specific. Number. Okay. N O or number lah. Okay. NUMBER. Okay. So this is all the variables in general. Okay, we have number 1, number 2, number 3, number 4, number 5. So we make it general because we want to make it simple. So we choose general names. Okay, enter number only. Alright. So to simplify this, we apply the accumulating equation. So how can we convert this into accumulating equation? Anybody? What do we want to accumulate over here? What variable that we want to accumulate?
Number.
Number, correct. So the equation is
Sum equals sum plus number.
correct. So this is similar with sum equal to sum plus number. So we will delete this later on. So we don't use this anymore. Okay. So I just put a comment over here. Side note. Okay, this is side note. Don't put this inside of your algorithm. Okay. So now we have this. Okay, we have this. Sum equal to sum plus number. So this is accumulating. This is counting. So this become accumulating. Okay, accumulate. Okay, class, understand? Okay, now, since we have accumulating process over here, again, similar with counting, we must have initial value. Okay, for accumulating, the initial value must always be 0. So which one that we want to put? Initial value, sum equal to 0. value okay, let me change the color. So this is element of accumulate. Okay, accumulate. Okay, what do we want to accumulate? We want to accumulate the number. So what is the equation for accumulating? So this is the equation for accumulate. Okay, for counting, so you must have this value. You must have the decision, and we put counter equal to counter plus 1 at the bottom. Okay, at the end of the while body. So where is the while body? While body is here. Okay, here, here, where we put indent. Okay, between while and while end is the while body. Okay, so now we have this algorithm. So let's test our algorithm. Okay, so let's say we have a memory over here. Okay, memory consists of counter and counter, number and sum. Okay, counter, number and sum. Memory kan, let's say this is memory So run the program. Okay, run the program. So counter equal to 1. So inside of the memory, counter value is 1 and sum value is 0. Right? So while counter is less than 6, and meaning that the system need to do decision. Decision is either true or false. So is it true or false over here?
True.
True, right? Counter 1. 1 is less than 6. So true, what happen if the decision is true? It will enter the body of the loop and it will do all the process within the body. So user need to enter number. So let's say user enter number 2. Okay. So sum will accumulate the number. So you see, sum equal to sum plus number. So sum equal to what? 0, right? That's why the initial value is very important. So let's say if you don't have this, so how you want to accumulate without the value, without initial value kan? Number, we have number already. Okay, inside of the memory we have 2. Let's say we don't have this kan? So we have 2. So 2 plus with what? So no value, right? That's why we need initial value to do the accumulate. Okay, so we have initial value 0. 0 plus with 2. So the answer is what? The answer is 0 plus 2, 2 lah kan? So updating the value of sum. So now the value of sum is 2. Okay, the current value. No more 0 kan? So I put this. This is a new line meaning the current value kan? So next, what it will do is it will do the counting. Kan? After do accumulating, next it will do counting. So what's the value of this equation? What's the value? What should I put over here? Anybody?
2.
Correct. Okay. 2 kan? Kan? Counter value is 1. Okay, initial value. This is also similar with sum tadi kan? So we must have 1. We must put initial value. Otherwise, nak tambah dengan apa kan? What should we add with 1? So this is initial value is very important for counting and accumulating. So you must put this value before while body. Okay, before you put while. Okay, before you put while, you must define the initial value of the counter, okay, the variable involving for counter, and the variable involving for accumulating. You must put the initial value. So normally we put counter equal to 1 and the accumulating variable we put initial equal to 0. So this can be a template, you know. You just apply this to any problem, you will be success. Okay, or success applying looping. Just apply this, copy and paste. Okay, as long as you understand. Okay, all right, so go back to here. So counter equal to 1 plus 1. Okay, so now the new value of counter is 2. Okay, is it end yet? No, right? Okay, so it will go back up and check the decision. Is counter less than 6? True or false?
True.
True.
True, kan? So now counter value is 2, which is still less than 6. So what happened? It will re-enter the loop body and do the same process again. So now user need to enter next number. Let's say user enter 4. Okay. So next, line 6. What is the value? What's the value, class?
6.
Correct. Okay. So 4 plus with the recent value of sum, which is 2. So plus 2 plus 4, you will get 6. So right now the value of sum is 6. No more 2, no more 0, kan? No more 2, no more 0. This is just to keep track of the value. Okay. So next, it will do the counting. What's the value? Anybody?
3.
Yeah, correct. So current value is 2 plus 1, 3. Okay. So reach end of the while. So it will go back up. Check the decision again. 3 is less than 6. Is it true or false?
True.
True.
True. Re-enter the loop body again. So now user enter number 10. Okay. Sum equal to what?
16.
16.
Correct. Counter equal to what?
4.
4.
Oh, correct. Reach the end of the while body. So goes back up again. Check the decision. True or false?
True.
True.
Alright, true. Re-enter the body again. So user enter 5. Okay, user enter 5. Next, what's the value of sum?
21.
21. Okay, what's the value of counter?
5.
5.
5. Okay, reach the end of while. So goes up again. Check the decision. True or false?
True.
True.
Okay, true. Re-enter the loop body again. Enter number. Now user enter 6. So what's the value of sum?
27.
27.
27. What's the value of counter?
6.
Okay, 6. Reach the end of while. So goes up again. Check the decision. Is 6 less than 6?
False.
False.
No.
False. So what happened? If it is false, it will skip the loop body, okay, and go to the next process, okay, the next process after while end, which is print sum. Okay, so it will print the value of sum. Which one the value that it will print?
27. 1 till 5.
27. 27, okay. The latest value, okay, the latest value inside of memory. So assume this is the memory. So the latest value is 27. Okay, it will print 27. So right now we have how many loop? How many looping happen, class?
5.
Huh? How many looping happen?
5.
5 loop. Okay, all together. So let's say we want to do a sum of 1,000 numbers. So what should we do to our program? What should we change? We want to do a sum of 1,000 number.
Counter less than 1001.
Counter less than 1,001. Are you sure? Betul eh?
Yes, sir.
Yes, sir.
Betul eh? Alright. So counter less than 1,001. Okay, boleh? So let's see if I change this to counter start with 0. So you don't need to enter to do a summation of 1,000 number. So what else should I change?
Counter less than 1000.
Yeah, counter less than 1,000. As long as there will be 1,000 loop, it's okay. Okay, it doesn't matter what's the value over here. Okay, do you understand, class?
Yes, sir.
Yes,
Let's
sir.
say
Yes, sir.
I want to use operator. I don't want to use less than. I want to use less than or equal to. So what should I change over here?
999.
999. Right. Okay. Alright. So the selection of operator also important. Okay. It doesn't matter what operator that you want to use, as long as the system able to loop within the requirement numbers. It's alright. Okay. Boleh kelas. What if I want to use equal equal? What should be the number over here? Can I use equal equal? Boleh ke?
I
No,
don't
tak
think
boleh.
so.
No.
Tak boleh kan? In this case cannot. But we will see later on there are some cases that require you to use equal equal. Okay, later on. Okay. So currently we stick with this one. So we use less than kan. For example, less than. Yang ni less than berapa? You start with 0, less than
5.
less than 5. Okay, everyone understand ah? So, tadi 1 6 kan. That's why we get this value, okay? Any question so far, class? So far, any question you want to ask?
No, sir.
Count
So
counter
this
mas number ke?
counter must number, sorry, this one. Counter ni.
Ah.
For accumulating, for counting, it should be a number. Okay. For counting, it should be a number. But, the but kan. But it can be string or character as well. Okay. But you cannot do counting kan. If you want to do counting, it must be a number, but it can be also string or character. That one we are going to see later on. Okay. Why we need to use other than numbers kan. In what cases we must use number. Okay. That one later on you will see. Okay. For now, I want you to understand the concept of while loop first. So if you want to do while loop, so what are the basic element that you need? You need to write down inside of your algorithm. So hopefully you can understand this. Okay, so you must have this one. Okay, the blue one must be pair. Okay, so this one should have 3. Okay, counter should have 3 element: initialization, decision, and the counting equation. Okay, next, if you want to do accumulating, you must have this equation and you must have the initialization. This comes together. Okay, let's say if your program doesn't involving accumulating, so you don't have this. Let's say if you don't do accumulating, so you will lack of the two process. Right. Okay. So this is a while. Okay. So similarly, if we do it using the flowchart, okay, using the flowchart. Oh. So first we have start, and then next what? If we follow this algorithm, after start, what else? What symbol should I use? Is it input?
Process.
The assignment. Okay, assignment symbol, right? Rectangle. Counter kan? So this is not input, this is not output. So this is assignment symbol. So you just put this inside of the symbol. Alright. Next is another assignment symbol. This is what, class? Decision, is it? So use decision symbol, which is
Diamond.
diamond. So what should you put inside? You put this don't put if if is for decision, while specifically for looping. Tak keluar ni. Color. Alright. Malah ni kena word ni. Okay, so decision similar with if decision, you must have true or false only. You cannot have more than that. It is either true. Let's say this is false. So this is true. So you need to write down lah true kan. Boleh lah sini true. True. E for true. This is false. Okay. So if it is true, what happened?
Enter number.
Enter number. Okay. So if it is true, we enter number. Kan? Then then what? After enter number,
Accumulating.
is it correct using this symbol?
No.
No, sir.
No lah, tu kamu ni pun. It's supposed to be input symbol, right? The number. Then this right. Sum. Number. Next. This one right? Betul ke? Betul tak?
Betul.
This one Next is what? Body of loop. This is true, right? True. So this is the body of loop. So what? Where we go? Where it will repeat lah. So how you want to repeat? So you must go back up again to the to here. Terbalik pula. Terbalik. Right. This okay. It goes up again. So this is here. This is here. Go up. Repeat. As long as the decision is true, it will repeat. So you see over here, this is actually a circle, kan? So from flowchart, you can clearly see there's a looping happen over there. As long as the condition, the decision is true. So it will repeat until the decision is false. It will goes out from the loop body and go to where? Go where, class? it will print sound. Apa je tu? Print sound. Di bawah lah dia yang confuse kat ni yang. Right, this. Bawah lah. Alright. And finally, don't forget, all programs should have N, kan? Ya, pergi N sini Ini adalah arrow kan? Aduh, nak clear kat ke? So, there will be arrow over here kan? Arrow, then arrow, kan? Kan? So, this is N arrow. Okay, guys. Boleh?
Okay.
Boleh.
Boleh.
Boleh lah, nak saya lukis ni kan. Any question?
Doktor, so print sum tu dia akan pergi dekat false tu punya lah.
Yes. So similar with the algorithm kan, you see. So this is true. Okay, if it is true, it will enter the body. Ini kan. This is for true. So if false, where it will go? Go outside kan, outside of the while. So where is outside of the while? Right under while end. So this is outside of while. Print sum. So it will print sum lah. This one similar lah. If false, print sum. Similar. Okay. Similar process.
So N dia pun sama lah pergi kat sebelah sana.
Mana? N. This is N. Mana yang sama? Maksud awak sama apa?
N pun dia pergi kat sebelah false lah.
Yes.
Okay, thank you
Yes,
doktor.
correct. Okay. What happen if we have a process that involving decision? Okay, and it happen repeatedly. Nak tak mana? If there is a decision that need to be do repeatedly. If else, if else, if else, if else, if else, if repeatedly. So you can put it over here. So there will be if, else, if. Okay. So over here, if true, there will be decision. If what? Okay. So later on we will do the exercise. Okay. Boleh kelas?
Boleh.
Boleh, sir.
Boleh.
Right. So this is just the first type kan. So we have 3 types kan. We have 3 more. We have 2 more So this is while end structure. Okay, next we have. Okay, let me just copy this macam mana ni? Copy everything Okay. Control C. Alright. Okay. So we want to look at the second types, which is repeat until, or we call it as do while. Do while is similar with while end. However, okay, the difference is on the location of decision making. Okay, while decision making is on the top of loop body. Okay, this is on top of the loop body. So this is the loop body. The decision is on the top of the loop body. But for repeat until or do while, the decision is, okay, over here we replace with do, and the decision we remove it to the end of loop body. Okay, where's the end of the loop body? Over here. So what you do is you replace this with the decision. Now it turns to do while. Senang tak? Kan? Copy and paste only. Okay, the rest is similar. So what's the difference? Okay, other than the location of the decision, this one, can you understand, class, how to convert while to do while? You guys follow?
Yes, sir.
Yes, yes.
Yes, sir.
Okay, just cut the decision, put it at the end of the looping body, and replace the decision with the word do. Okay, so this will indicate the starting point of the decision. Okay, this will indicate the starting point of the decision. Boleh eh? Alright. So what's the difference with this? Okay, so let me show you what's the difference. Example. Okay, this is example. Example. I say example only, right? So this one you should remember. You should have counter equal to 1 or 0, sum equal to 0. But let's say I change this to 6. So what happened? Okay, counter equal to 6, sum equal to 0. So while counter less than 6, is it true or false?
False.
For
False, what happened? Is it going to enter the body or not?
No.
No.
No, it will straight away go to while and print sum. Correct?
correct.
Correct. Okay, it will not enter the body at all. Okay, but if you are using do while, so let's say this is the value, okay, counter equal to 6. So what will happen if it reach to the looping? Is it going to enter or not?
Yes.
Yeah.
Yes.
Yes, right, because there's no decision over here. So it will enter the body of the loop, it will do the process, and then when it reach the decision, it will go out or repeat. Decision true or false?
False.
False again. So 6 plus 1, 7. So 7 less than 6. False, right? So we go out and print sum. So what can you see over here?
They
So what,
print the false.
so what's the difference? Using the same value but different structure. So what can you say about this? The difference between while and do while.
Dia calculate yang salah tu.
Okay. But in terms of the flow, okay, although the decision is wrong, okay, the statement inside of the loop body will be executed at least once for do while. Okay, for do while, although the decision is false, the statement, okay, the process within the loop body will be executed at least once, although the decision is wrong. Okay, this is different from the while. Okay, as long as the decision is false, it will not enter the loop body at all. Okay, it will not execute any of the process at all. Zero, kan? Zero process executed if the decision is wrong. Faham? So, faham tak?
Faham.
This one wrong, but it will execute once and then it will go out of the loop. So that's the difference. Okay, please remember the difference. Right, so I change this back to 1 lah. So this is the correct value for both. Both will enter the looping. So what about the flowchart? Okay, so we look at the different in terms of algorithms. So for flowchart, what do you think we must change, class?
Decision tu letak kat bawah.
Kan? Simple only. So identify which is the end process of the loop. So this is the loop body. The end of the process is counter n. Counter equal to counter plus 1. Okay, similar with this. So the end of the process is counter, the end of the process is counter equal to counter plus 1. So what's next? So you must move this into the end of the loop body over here. Alright, so this will go here lah. Okay, so if true, okay, if true, it will repeat or not?
Repeat.
If true, it will repeat. So where the starting point of the repeat? Kan? So this is why do is important kan? So you must go to the sinilah. Kurang So this is where do. This is where you put do lah. So this is do. Just put do, okay. Then you are good to go, okay. Okay. So what happen if it is false? Okay, true, repeat again. So repeat until it is false. It will go to
Print.
Print sum n.
okay, same process. So you can, doesn't matter where you put this, as long as the arrow is correct, okay. The placement is not important. Important is the arrow. Okay, the process. Arrow indicating the process. If the process is correct, then your flowchart is correct. Okay. So this is do what? Yeah.
Dekat do while tu tak ada end while tak payah ada
No.
Ah,
The end statement is the decision for do while. No end while.
oh, alright.
Okay. Any more question? Do while. If no, we will go to the final structure. The for loop, okay, which is also we call as automatic counter loop. Boleh? Okay. Alright, so it is easy to understand the automatic counter loop if you already understand while. because the flow is similar. The flow is similar. However, how you write it is slightly different, okay? It is right. Okay. For automatic counter loop, okay, so what you need to change is we change from, if it is algorithm, we change the decision into loop. Counter equal to 1 to, what is the end of the looping? The end of the looping is, if you
6.
want, if you want it to loop 5 times, then you must be end with 5. Okay? It must be end with 5. So over here is the initialization. This is the decision. So counter must equal to 5. Okay, in order for it to, okay, meaning that it will loop 5 times lah. 1, 2, 3, 4, 5, 5 times. Okay, so you will not needed this anymore. Okay, so there will be no initialization. So I will remove this. Right? Okay, just to show you the difference between while and automatic or for loop. Okay, this is the difference. So we put the initialization along with the decision. Okay, decision, initialization, and decision. Okay, so the rest is similar, and then over here the end, we change it to loop and also the name of variable that we choose as a counter. In this case we use counter lah. Counter je kan? Same name. Okay, counter. Okay. Kalau C besar, capital C, all must capital C lah. Consistent, okay. Alright. Okay. Then, the one that we should remove is this one. Right? Since we already put all together inside of the decision. Decision initialization, and also there's actually 3 over here. Initialization, decision, and counting within one line. Cover 3 elements. Okay, if we are applying loop for using, if we are applying while to do the loop, we need to separate these 3 elements, initialization, decision, and counting. We put it in the separate places. But if you are applying automatic loop or for loop, so we combine all together these 3 elements within one single line of process. Boleh kelas?
Boleh.
Okay, so that's the difference. How you read it, still similar. Okay, similar. How you want to read this, then since it is already packed in one line, so you need to imagine it. Okay, you need to imagine this like you read while loop. Okay, imagine. Okay, over here, sum equal to 0. Before you enter the loop, counter equal to 1. Okay, and then it will check the decision. The decision or the counter already exceed 5 or not. If not, it goes again. Enter. Okay, we enter the body. Okay, and then over here at the end of the loop body, it will do counter equal to counter plus 1. Okay, and then it will check the decision whether already exceed 5 or not. If not, it will enter again. So how you read? You read it like you read while. Okay, but in terms of writing, this is how you write. Okay, it is simplified. Boleh? Boleh kelas?
Boleh.
Boleh So this is algorithms. Okay, for automatic looping. Okay, for flowchart. Okay, flowchart also have been simplified. Right? Okay, the same body, however, apply. So the same body. Okay, but since we don't have counter over here, so counter already combined with the decision and initialization. So we remove counter ni kan. So we remove counter. Okay, like that. And also obviously this should be changed, right? So this one also remove since we already combine all together inside of one symbol. Okay. So straight away it will start and sum equal to 0, and this one we need to change this into this symbol. Ni apa panggil lah? Hexagon eh? 1, 2, 3. Hexagon ke octagon? Ke pentagon? I'm not sure the name Okay, this symbol So this is the symbol that combine all three elements together. Okay. So what should you put over here? Okay, first you put the variable name that you use as a counter. Okay, in this case we use counter, right? So you put the variable name. Okay, 5. Susah pula. No field, no line. Okay. It. Susah pula. COUNT, counter. Nampak tak kelas? Can you see? This is counter very small Counter Can you see this one?
Yes, sir.
Boleh
Can.
Can Okay. And then what else you need to put is the initial value. The initialization. Ni kan. Initialization of counter. Counter equal to 1 kan. If the initial value is counter equal to 1, okay, this is the initial value. So you put initial value over here at the left side of the symbol, which is 1. Okay, if you start with 0, then you put 0 lah. Okay, this is initial value of counter. Okay, so next what you should put is loop the end of the loop. So in this case 5. We want it to be looping 5 times. So you put 5 over there. Oh, so small Nampak pula. You put 5. So this is 1. Okay. And then the incremental value. Okay, the incremental value. So over here we increment by 1, kan? Plus 1. If you increment by 2, you put 2 lah. This case for the counting, okay, generally we use plus 1. Okay, counter plus 1. So plus 1, you put it over here. Okay, plus 1 over here. So everything is related to the counter. Okay, counter start with 1. Okay, counter equal to 1. So this one similar to this. Okay. Next, counter, the end of counter is 5. So 5 including 5 lah. So this is similar with counter equal to 5. Something like that. Okay. So the end of the value of counter is 5. So 5 is still true. Okay. This will be considered as true. And then from 1 to 5, it will be increment by 1. So 1 plus 1, 2, 2 plus 1, 3, 3 plus 1, 4, 4 plus 1, 5. Okay. So to get from 1 to 5, it will be increment by 1. Okay, this is similar with counter equal to counter plus 1. Simplified version. Okay, that's it. So this is if it is true. So if it is false, so similarly it will go to print sum. Okay. Alright guys.
Okay, sir.
Any question?
So can the beginning value be 0?
Beginning value can be 0. Okay. So if you put 0 over here, so if you want to loop 5 times, so it should be what over here?
4.
Should be 4. Okay. Okay, so this one also similar. So you start with 0, 0, 1, 2, 3, 4. Okay, 5 times then. 0, 1, 2, 3, 4.
Okay, thank you, sir.
Right. Okay. So if no questions, so let's do some exercise. All right. So this one you can refer to column. Okay, we are going to okay, use okay, so previously in week 4, okay, go to column, okay, go to week 4, okay, we are going to use the same question. Ni kan? Let week 4 question. Okay, you can open this. Okay, actually this one is okay, this question. Okay, the one that we already discussed, the one that we already done is question 1. Correct. Question 1 already done. Okay, before the midterm. So what I want you to do is do question number 2. Okay, do question number 2. Alright, positive logic, negative logic, and algorithm. This one we already discussed last week. In brief, positive and negative logic. Okay. So this is doesn't involve any looping and so this is just decision. Okay. So this is what I want you to submit for today. No looping, no looping. This is decision. Okay, looping we do tomorrow. Okay. So this is very important for you to do because tomorrow also we are going to have the second quiz. Okay, second quiz up until this topic. Okay, positive, negative, and also another one is what straight through logic. Kan? There are three types of decision structure, which is positive, negative, and straight through logic. So this will be covered in your quiz 2 tomorrow. Okay, quiz 2 is going to be online. So I will open the quiz right after our class. Okay, our class is from 8 to 10 a.m. Okay, after that I will open the quiz 2 and you can answer any time that you are free. Okay, the last you can answer is before midnight. Okay, before 12 midnight tomorrow. Baik kelas? So for today, submit question number 2. Okay, this one, where to find this? Go to week 4. Okay, download the same question that we already discussed. Okay, but answer question 2. So this one question 1. So answer question 2. Submit before 12 midnight today. Where to submit? Submit in week 6 link. Okay, week 6 lecture, week 6 submission. So submit over here. Am I clear, class? Clear tak?
Boleh, sir.
Yeah.
Yes, sir.
Boleh. Alright, so we have another 30 minutes, so you can proceed with the exercise. Okay, so that's all for today. Okay, thank you. And see you guys tomorrow morning. Jangan lupa tomorrow morning 8 a.m. Okay, thank you guys. Assalamualaikum.
Okay.
Salam. Thank you, sir.
Thank you, sir.
Thank
Thank you,
you,
sir.
sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Waalaikumsalam. Thank you, sir.
Doctor, thank you.
Thank you, sir.